here we go with Unit 4. Hope you've had a good week, and hope that you're keeping up pretty good in the class. So far, it's been exciting for me, and things are going good. This is a really unique unit because we're talking about energy. And you've heard a lot of things that we're going to talk about, but in terms of chemistry and thinking like a chemist, the thing we've got to think about in terms of energy is we've got to think of the energy of things we don't see. Like even in this atmosphere, we've got to think about electrons. Molecules are made up of electrons, neutrons, and protons, but those neutrons and those protons are stuck in that nucleus, but it's those electrons that are going around that are keeping everything intact, and they're traveling at the speed of light. So all of a sudden we have something 186,000 feet per second. So all of a sudden we have to look at energy in a different light. We have to look at energy as a chemist would look at energy. But to define energy, energy is simply the ability to do work. Well, work, the science definition for work, is moving an object through space. So, for example, somebody that comes up, that pushes on this board extremely hard, and they come up, and they push, and they push, and they push, but they don't move this. In our terms, we think, well, they've worked hard, but in science terms, they haven't really done a lot of work because of the formula for work. The formula for work is equal to force times distance. So, if something is not moved over a period of time, then we don't have work. Well, this is really significant for chemistry because electrons cover a lot of distance. So even though you don't see those electrons traveling 186,000 feet per second, from here to Los Angeles in 20 minutes, okay, but there's an incredible amount of energy in electrons. So we have to understand that to understand chemistry. Now, you probably have had this before, but two types of energy. Potential energy is stored energy, and kinetic energy is energy in motion. So what we have in chemistry is pretty much all kinetic energy. Electrons don't stop moving. We'll talk about that a little bit later when we talk about absolute zero. But we have the law of conservation of energy. Energy can't be created or destroyed. Energy only changes forms. So in chemistry, we have to account for all of the energy. Now later we're going to learn that the law of conservation of matter says the same thing. Matter can't be created or destroyed. It only changes forms. There's the same amount of energy, the same amount of water, the same amount. The day that this earth was created, the day that this earth started, there was the same amount of energy as there is today. So as a chemist, we've got to look at that. We've got to say, okay, so what's accountable? Where's this energy at, and where's it accountable, and what's going on? So when we talk about a chemical reaction, there's three parts of a chemical reaction. Now, as I go, some of you may want to stop and start this. We're going pretty fast, but these are the notes, and as you're beginning to get used to the test, these are the notes you're going to have for your next test. Your next test, once again, will be over this Unit 4, and the next unit, Unit 5. So you're getting the hang of it. Hang in there. So three parts of the chemical reaction. We have the reactants, yields, the products. Well, it's kind of like making a cake. All of the reactants, so that would be like the ingredients, everything that's in the reaction. We're making a cake, and I'm not a great baker or cook, but we might have eggs and flour, and if we're making pineapple upside down cake, we might even have the pineapples and the cherries and the brown sugar. All of these ingredients make up the reactants. The reactants have to go through a chemical change, and that's why we put yields, and then we have the products, the final product. So once again, why are we doing that? Because we've got to say the law of conservation of energy. Energy can't be created or destroyed. Matter can't be created or destroyed. A chemist is accountable to show all things. Later on, we'll do half reactions. We'll show even where the electrons go. So what starts a chemical reaction? Well, it's called the activation energy. Activation energy is the energy needed to start a chemical reaction. Sometimes the activation energy is simply just the motion of the electrons moving. Other times it might be a fire, or it might be a pH change, or some type of thing starts this chemical reaction going. So once again, activation energy varies in a lot of different ways. Now, as we move over here to the other board, we talk about exothermic versus endothermic. All right. So